Hello everyone. Through this video, we'll discuss how to create multiple threads in Java. Okay. So in last video, we have discussed the life cycle of thread. That means one thread can be present in out of any of the five states. That is your new state, runnable state, running state, block state, and terminate state. Okay. Now today we'll discuss how actually we'll create multiple number of threads. So basically, there are two different types of approaches are available in Java through which you can create a thread. So first approach, you can say that you have to inherit the thread class. Okay. So if you have watched the video of custom exception, then whenever you are implementing or designing your own exception class, you have to inherit exception class to get all the predefined methods or resources of exception class. Similarly, whenever you want to create a thread, you have to inherit the predefined class thread. Why? Because multiple number of predefined methods are available inside thread class. Okay. Now the second approach that you have to implement the runnable interface. Okay. So also we'll discuss why there are two different types of approaches are there for a single problem. Okay. Now you can see this is what the syntax for creating one thread by extending thread class. Okay. So you have to write down your class name, whatever the name you want to provide, but you have to use this keyword extends and the class name. Okay. But why actually you are inheriting thread class? Because thread class actually provides the start method which is used to bring the thread from new state to runnable state, and it also provides run method to perform the actions. Okay. So how actually will implement these two methods? Let's see through the example. Create thread using, or you can say by extending thread class. So first of all, you have to write down your own exception class name, which will extend thread class. Okay. Now inside this, suppose I am writing one variable item, and we'll define the run method. This is what the most important work you have to do. So all the operations or thread execution depends on the run method. Okay. Okay. So I'm printing the value of item. Done. So I have defined the run method where I have used a for loop to print the value from 1 to 100 inside the class. Okay. Now we'll define the main method. Okay. So you have to create the object of your own exception class. Okay. So my exception demo ob1 equal to new my exception, and here you have created one thread. Clear? Now once the thread is created, it will enters to new state. Clear? That means now the thread is currently created, but you can bring that one to the runnable state. Okay. By calling the start method. Done. Fine. So this much you can do. What you are capable of doing, you can create a thread. Okay, like you are creating the object, and once you are creating the object or thread, now it is moving to the new state. Okay, or newborn state. Now you can call the start method to move the thread from new state to the runnable state. But how, you cannot call the run method. Why? Because run method depends on the availability of the processor. Clear? When the processor will be available, the corresponding run method of OB1 will be called. Okay. Now here inside the thread class, remember, inside the thread class, run method is available, start method is available. If you have watched the video of thread lifecycle, then you have seen suspend is one method, resume is another method, notify, wait, sleep. So similarly, number of predefined methods are available inside the thread class. And as your class is inheriting the thread class, now your class will be the child class of thread class and can access everything directly. Like I am calling the start method here. Okay. So once I am calling the start method, the thread will move to the runnable state. That means it will declare itself that I am ready for execution. Okay. But for execution, the run method needs to be called, and it depends on the availability of the processor. If not a single thread will execute its run method, or it is not using the processor, now processor will be available to the thread OB1 and its corresponding run method will be called. So run method is independent of user. It depends clearly on the operating system. Okay. So let's save the file. Okay. Oh, why this is showing error? Okay, so this is a normal mistake we used to do, because the signature needs to be same whatever is present inside the thread class. So run method is present inside the thread class with a signature of public void run, and whenever you are overriding, clear, you are overriding the run method, so you have to provide the exact signature, because if I'm not writing public, it will be treated as default. That we have already studied in package chapter. Okay, so public you have to write anyhow. Then see, I'm getting all the values from 1 to 100, but this is normal. Normally here we have learned that we are not calling the run method, but run method is being called by OB1. But how to know whether multi-threading has been achieved or not? Okay, so what I am doing, I am creating multiple number of threads. Like OB1 I have created, I am creating OB2 and calling the OB2 dot start. Similarly, I am creating OB3 and calling OB3 dot start. Okay, so that means what I have done, I have created three threads. One is your OB1 is one thread, OB2 is another thread, OB3 is another third thread. So after they are created inside the thread pool, now if you want, I can write everything combinedly. Okay, so everyone is created, all the threads are created sequentially, and they are available inside the new state. Okay, now by calling the start method, I am bringing those threads from new state to runnable, so all are available inside the queue. Okay, runnable queue. Now let's execute this one. Done. Okay, so let's see the values. So 1 2 3 4 5 6 7 20 34 45. See, after 51, I don't know which thread is running, because till now you have not studied how to know the thread name or ID. That we'll see in our future video. But remember, once a single thread will execute as per your calculation, its run method will be called 1 to 100 value needs to be printed. Then the second thread should start. But here I am getting the values up to 51. Then suppose thread 1 is being executed for OB1. Okay. After that, now due to some problem, now switching has happened and I am providing the control or the run method of thread 2 is being called. After executing two instances, now thread 1 is again continuing. Now this is for thread 3, then again thread 1, then thread 2, then thread 3, thread 1, then thread 3. So the switching will be done in between the threads. Clear? So run method will be called on the basis of the availability of the processor. Okay, and switching will be done on the basis of the availability of the processor. Clear? So if you run any time, you will get some different output. Okay, any number of times you'll see. I am executing this one. So first thread is created, 1 2 3 4 up to 51, 1 2 52 53 154. Again I am getting 2 3 4 5. So number of values or different kinds of output will get by executing multi-threading. Clear? So in multi-threading, you can understand the user is having the control up to this one. You can bring the thread from new to runnable, but how they will execute or how their run method will be called, it depends totally on the availability of the processor. Okay. So this is the first syntax. By extending the thread class, you can implement multi-threading. Okay. So that's why you have written that thread class provides start method and run method to perform the action. Okay. Now the second approach, you can implement runnable interface to achieve multi-threading. Okay. But why actually runnable interface is required? Now remember, suppose your class myThread is extending thread class, and as per Java concept, this class myThread cannot inherit it any other classes if required. Okay, so that means if myThread class wants some properties from XYZ class, it cannot do. Why? Because to achieve multi-threading, it has inherited thread class. Okay, so if I can achieve multi-threading through another way, then there is an option that I can inherit my class whenever I require to get the properties. Okay, so to achieve multi-threading, we have experienced the run method is the most important method which needs to be executed. Then only my task will be done. Okay, so for that, the Java software people, they have defined one interface known as runnable, where they have kept the run method only. Clear? Because they know that this is only the requirement for the programmer. Clear? Okay, so to inherit the properties of another class, you have to implement runnable interface to achieve multi-threading. Clear? So let's see through the example. The same example I am copying so that you will understand what is the difference between both the concepts. Clear? So create a thread by implementing the runnable interface. Okay. So instead of extends, you will write down implements runnable. Okay, rest of the code I have kept same. Check. But here, whenever I'll create the object, I'll call the start node. Suppose I'm doing the same thing. Okay, so here it is 1 1 1 because you have modified the class name. Okay, so let's, I am doing the same thing whatever we have done in the previous example. Clear? Okay, so read the error. Cannot find symbol. Which symbol? Start. Because method start is the symbol. Okay, so start method is not found by OB1, OB2, and OB3. Why? Because you have discussed that the runnable interface only contains run method. It doesn't contain the start method. And here the problem has been started. That runnable interface doesn't have start method. And unless and until you will bring the thread from new state to runnable, its run method will not be called. Clear? So runnable interface provides run method, but to call the run method I need to start the thread. Okay, so here I have to take the help of thread class. Okay, so thread ob equal to new thread. Clear? And inside that thread I am passing the ob1 object. Okay, so indirectly my ob will start calling the start method, because ob can call start method is available inside the thread class. So I'm calling the start method by using ob, but this thread ob will initiate the execution of ob1 thread. So indirectly thread class is helping to start the execution of ob1 thread. Okay, now similarly thread ob5 equal to new thread, and you will pass ob2. Clear? And here you will write ob5 dot start thread ob6 equal to new thread ob3, and here ob6 dot start. Okay, so start method belongs to thread class, so I am taking the help of one thread class object to initiate the execution of my multi-threading concept. Clear? Okay, so let's see. Perfect. See, I am getting the values like extending the thread class. So similarly 10 multiple 1 2, then 1 2 3 4 1 5 3 5. So number, the execution will change all the time whenever you will execute the program, because it depends on the processor. You don't have any control on that. Okay, so we have learned that the thread creation can be done by extending the thread class or by implementing the runnable interface. Also you have studied why there are two different types of solutions. Okay, so thank you everyone for watching this.